Welcome to qnawire.
Welcome to the problem number 22.52. In this question, we are given that there is a uniformly distributed charge over the sphere which has diameter 30 centimeter. So the radius would be 15 centimeter. So we have electrons here. So electrons are distributed here. So due to this electron charge, we have a charge on this sphere. So this charge is distributed over this sphere, and we are given that the electric field at the surface is 1390 Newton per coulomb. So we have E equals to 1 over 4 pi epsilon naught Q over R square. And in this case, R is at the surface, so R will become D. So this would be 1 over 4 pi epsilon naught Q over D square. So putting all these values here, so E is equals to 1390, which would be 4 pi epsilon naught here, and times d square. So this will give us q. And we know that one electron charge is equals to 1.6 into 10 raised to minus 19 coulomb. If this much charge is due to the number of electrons of this much, so we can find the number of electrons. So this would be Ne equals to Q. So N gives us Q over E, where E is equals to 1.6 into 10 raised to minus 19. So we can find out the number of electrons using this. So let's find out the Q here. So Q comes out to be 3.479 into 10 raised to minus 9 coulomb. So this would be 3.479 into 10 raised to minus 9 over 1.6 into 10 raised to minus 90, because each electron contains this much charge or has this much charge, and to have this much charge we should have n number of electrons, and which is exactly equal to this quantity. So the numbers comes out to be 2.17 into 10 raised to about 10 electrons. So that is a huge number of electrons to make that much charge. And that should be because electron contains very small quantity of charge, which is 1.6 into 10 raised to minus 19 coulomb. So this was your A part. Now going to the B part. Now we need to find out the electric field at r equals to 10 centimeter. So if you convert this one, so this would be 0.30 meter, and the radius was actually 0.15 centimeter. So we are now finding out at zero point 0.1 meter. So let me correct it. So this is 0.15 meter. So yeah, 0.15 meter. Now going to this one, so we have electric field. So now this is r prime. We're given that it start from the surface. So the r from the center would be, or let's say d prime, the d prime would be r prime plus d, which is equals to zero point 0.4 meter, because this r prime is given from this surface. So this is our point, which is r prime, or this is our r prime. So this would be r plus d prime. So r prime plus d. So this would be equals to d prime, which is equals to zero point 0.4 meters. So we are finding out at d equals to zero point 0.4 meter or d prime. So again using this formula again, 1 by 4 pi epsilon naught q over d prime square. So q we already know. So q is our 3.479 into 10 raised to minus 9 over zero point 0.4 square. So this comes gives us equals to 5 into 10 raised to power 2 Newton per coulomb. So there is an electric field at that point, or r prime, which is at zero point 0.1 meter from the surface of the sphere. So that's your answer for this question. Thank you for watching the video.